Can you learn data science, even if you don't know anything about data science at all, or even Python, in just an hour? You can. I'm going to teach you the basics of data science and Python along the way. And we're going to break down the concepts so that they're very easy to understand. And you will actually, for the first time in your life, understand and use slope-intercept form. Let's go. So first off, the tools that we're going to use today are Visual Studio Code and something called Anaconda. Anaconda is a tool that you can install that will make setting up your data science environment a lot easier. We have a video to show you how to do that in just a few minutes. You can pause, take a look at that video, and then come right back. It's not a complicated process. So to get started, let's first create a folder where we'll put all of our code. So I'm going to create a folder here, and let's just call it Explore Data. And then I'm going to open this in Visual Studio Code, and you can do that by just dragging and dropping the folder onto Visual Studio Code. Now we have our empty folder open, and we want to write some code. Now, data scientists use a lot of tools, but one of the ones they use the most often is something called Jupyter Notebooks. So if we look in our extensions here, we can install Jupyter Notebooks. The other item that we can install if we want to, probably better even, is just install the Python extension for Visual Studio Code, which gives you IntelliSense and linting and also Jupyter Notebooks. I already have this installed, so let's go ahead and create a new Jupyter Notebook. So we'll do the new file and call it student data. We're going to be working with some student data today, exploring students who passed and failed a class and trying to figure out what happened there. Let's go ahead and create this notebook here. And in a notebook, we have these things called cells, and we can write code in the cells and execute them. We can also use something called Markdown, and Markdown just lets us annotate student data, right? This notebook analyzes pass-fail data for a class, okay? And then when we hit the little check mark here, it just adds that text to the notebook. All right, so let's go ahead and add a new cell and put some code below. So first off, we just need some data to work with, okay? So let's just bring in a Python list, which is what we have here. And we're gonna set it equal to the data variable. And that variable data now exists, but how do we see it? Well, there's a variable explorer here in Visual Studio Code. And if we open that and scroll down a little bit, here's our list here. It has 22 items in it. Another thing that we can do is that we can just print out from the cell what's in the cell, right? So we just say print data, and this will print that out below the cell here. So these are all of the items that are in the list. Now, lists are great for working with data in Python, but they're not so great for working with numerical values. And a lot of data science is statistics and math. And so there's a package called NumPy that actually has an array type that's better for this. So let's add a new cell here, and we're going to import NumPy as NP, okay? And then let's create a new variable called grades. And then we're gonna set that equal to NumPy, and we're gonna create a new array, and we're just gonna pass in that data object that we have from the first cell, which will give us an array. And then let's just print out that grades object here. Okay, so these two objects look the same. What's the difference? Well, the most obvious difference is that there's commas here, but not here. But the real difference is that the array, this here, is much better for doing mathematical operations. Let me give you an example. So up here, if we take this data list object and we multiply it by 2, what do you think will happen? Let's run it and find out. It actually doubles the number of objects in the array, right? So here's the first set, okay? And then here's the second. It literally took the array, multiplied it by 2, and gave you twice the objects in the array. Okay, so what happens when we multiply this grades object by 2? In this case, it takes the array and it multiplies each item in the array by 2. So arrays in NumPy are much better for working with numbers, for doing mathematical operations on those numbers. All right, so let's go ahead and keep on working with this array object here. Now, one of the things that we can do is we can take a look at the shape of this array. So let's do that. So we can see that there are 22 items in this array. Another way that we can see this is if we go back to the variable explorer here, here's our grades array. We can open that up and take a look at it. And you can see here the same thing, 22 items in the array. And when the variable explorer launches here, we can see all of those items here. Now, notice that each one of these items has an index, and this is added for us automatically. And arrays start at 0. Okay, so the first item is always in the 0 position, and then the second item is actually in the first position. When you first get started with programming, it's a little tough to wrap your head around, but you'll get the hang of it very quickly. So knowing that, let's look at how we can get items out of this array. So for instance, if we wanted the first item in the array, because arrays start at 0, we would put 0, and this would give us the very first item. That's this item here, okay? Now, if we wanted to get the 47, that would be 0, 1, 2, right? So if we change this to 2, we should get 47. And if we wanted this 3, that should be 0, 1, 2, 3, 4, 5. This should give us the 3. Okay, so what else can we do with arrays? Well, we can do mathematical operations on the whole array. So for instance, if we wanted to figure out what the mean score was, okay, so the average test score here, we could do a mean on the array, and we see that it's a 49. Must have been a really hard test. So what we want to do here is determine why the scores are so low. So to do that, we need to bring in some additional data into this array. And what we want to do is bring in the amount of hours that each student studied along with their grade. So let's go ahead and add in this study hours, a list item here. And then what we want to do is just say we have a student data, new object called student data, and we're going to set that equal to the NumPy array, okay? And then inside of that array, we want to have two objects. We want to have the study hours, which is the number of hours each student studied, and the grades, okay? And what this is going to do is create an array with two arrays inside of it. Let's go ahead and run this. So let's take a look at this in our variable explorer here. So if you pull it up, you can see we now have two arrays inside, and each array has 22 items. And if we were to pull that up here in the variable explorer, here's the array 1, which is the study hours, and here's the second array, which is the grades. Now, when you're working with an array that has multiple arrays inside of it, how do you get a single item from one of those arrays? Well, let's take a look at our student data here. And if we pull back the first item, the item in the 0 place, we're going to get the first array. And if we want the first item from the first array, can you guess what we need here? Another 0. So we're going to get the first array, first item from first array. So it should be 10. So let's run that. Right? If we wanted the first item from the second array, that would be 1, 0. Okay? All right, so let's do some analysis here. So let's go ahead and do a couple of things. First, we want to get the average study time. So let's go ahead and create a variable that's the average study. And let's get the student data, right? And the study hours was in the 0 position, the first array. So we're going to get the mean of that array, the average. And then let's get the average grade. Okay, so that would be student data, same thing here. And actually in VS Code, we can just copy this line down with Command or Alt Shift down. It gives us the line over, and it just makes it easier for us to code here. So we can say average grade, and then we'll just change this to a 1. And then let's go ahead and print out what this is. So in Python, that's a print statement. And you can use this formatted string, so F and then a string, and we can say average study time, the colon, and then we use these little brackets and we can put the variable right in there. So average study. And then on another line, which is \n, we'll put the average grade, same thing, average grade. And you can see Visual Studio Code's helping us out here. This character here is called a carriage return, line break. Just puts this text on a different line. Whoops. Okay, let's run this. And the average study time was 10 hours and the average grade's a 49. How'd you like to study for 10 hours and still get a 49? I'd like to know what was on this test. When we're dealing with multiple arrays inside of an array, it can start to get kind of confusing, right? Just the idea of having arrays inside of an array starts to get tough. And so there's a package called Pandas that will allow us to work with this data in a table, which is going to be something that looks a lot more familiar. So let's do that. So let's add a new cell here, and we're going to import a package called Pandas. Now, if you're running this and you get an error saying that the package couldn't be found, what you can do here in your terminal, if you have Anaconda like I do, is that you can just issue a conda install command and then install the package that you're missing. So in this case, we could run conda install pandas, and that will install pandas. So if you run into any of those missing package errors, give that a shot. Let's go ahead and make our data set a little bit more complicated. So to do that, what we want to do is create this thing called a data frame in Pandas. A data frame you can think of as a table. And we're adding some data here. So we're actually putting the name of the student. So this is new data. And then we have the student data, right, which is our study hours, the first array from student data, study hours. And then the second array from student data, the grade, we're putting in grade, right? The difference here is we're actually naming these things now, so we actually know what they are. And we can go ahead and look at this thing, which is called a data frame, and see its structure. So we can print it out here from the cell, and you see it just looks more like a table. We're still working with multiple arrays. This is a structure that probably just makes more sense to your brain. This is called a data frame. It's provided by Pandas. The other way that we could look at this is if we come to the variable explorer here, and we go down and look for our DF students, which is our data frame. You can see there's 22 elements, and it's got 3 arrays inside of it, right? But when we open it up, it looks more like a table, which is a data structure we understand kind of like a spreadsheet. All right, so how do we work with data frames? Well, let's take a look at how we can get an item out of a data frame. So in a data frame, let's say we wanted to get the first item. Now with an array, we would just do 0, right? So if we wanted the first item from the first array, it would be 0 and 1. If we run this on the data frame though, we get an error because data frames don't work that way. What we need to do instead is we need to use the LOC method. And then we can pass in and say, give us the first item here. And the first item it's really a row, right? So it's Dan's study hours and Dan's grade. It's that first row. And if we were to go back and look at the data frame right here. So if we wanted, for example, Vicky in the 5th position here, we could go ahead and just pass in 5. And that will give us actually Vicky, who only studied for an hour and got a 3. Ouch. Now, let's say that we only wanted to know the grade from Vicky, right? So we want the item in the 5th position, but we only want the grade. So we can actually pass in here as a second parameter, the column that we want back. And because the data frame knows about the column names, we can just tell it the grade column. And if we run this, we just get back the 3.0. And if we change this to name, we should get back just Vicky. So there's a lot of other ways to get stuff out of data frames and searching for data. So one of the ways is to use filter expressions. So we can take this data frame of students and we can say, for the name column, give me the data where the name equals Vicky. That's what this expression says here. So let's run this and we get Vicky and her study hours and terrible, terrible grade. Now, another thing that we could do here, instead of doing it this way, is we can use something called the query method. So we can write query here, and then we can actually write a query, which is a string, but it's essentially the same thing. We just say where name equals Vicky, but Vicky has to be in quotes because Vicky is a string data type. So if we run this, we should get back exactly what we had before, but we don't because I left out an equals. The double equals is important, and now we should get back Vicky. There we go. All right, another thing that we can do here is if we go back to the way we were doing it before, where we're saying DF students, we can actually just hit the dot here, and then the data frame knows about the columns that it has. So it knows that there's a grade column here, right? Or it knows that there's a name column, and then we just do equals and say Vicky, and run this, and we'll get back Vicky. And this is the method that we'll be using for sort of the rest of this video to access data in a data frame. All right, so those are the fundamentals of a data frame. Sort of back up and take a look at a more real world scenario, something you might actually do. So it's common in data science to import data from some sort of an external source. In this case, we're pulling in a CSV file. So we're downloading a CSV and then we're loading that CSV into a Pandas data frame. So we're reading in the file, the delimiter is a comma, and we're inferring the column headers. So let's just run this so that we can see how it works. So if we run this here and then look at our file explorer, you'll see that the CSV file actually gets downloaded, right? And here's the CSV file. Here's the name, the study hours, and the grade. It's kind of like a table in comma separated format. So what we have here, and let's go ahead and clear the cell output to make this a little less messy. And if we look at this data frame again, this DF students, it's going to look exactly like it did before, only this time the data has been loaded from this CSV file instead of us just loading static data. Because usually data scientists are working with lots and lots and lots of rows, thousands of rows. But this data is a little bit different. And the difference is that it's a little bit more real world. And one of the ways that it's real world is that there are some null values somewhere in here. Okay. So one of the first things that data scientists have to do is they have to clean up the data so that they can actually work with it. So in this case, to find any missing values, we can say df students and then just look for is null, right? So if we run this, it will tell us whether or not the value in each column is null or not null. So in this case, false. It's not null in any of these places, but this isn't super helpful for us. There is a better way for us to see exactly which values are null. So first of all, we can here and just say sum and just get a sum total of how many values we have that are null in each column. So there's one value that's null in study hours and two values that are null in the grade column. So the next question is then, well, what do we do about that? Well, there's a couple different things that you could do. One of the things that we could do here is we could go ahead and replace any missing value with an average value, right? So for missing a grade for student, one of the things we could do is just replace that with the average of all the other scores since we don't have a score for them. So what we can do here is we can fix just the study hours column to start with. So let's go with df students and then study hours. So we're going to set that equal to, and then we're going to fix the missing values inside of that column. So we're going to say df students dot study hours dot fill in A. And basically we're telling it we're going to fill in all of the missing values. And then in the parentheses, we need to tell it what we're going to fill it with. So we're going to fill it with the study hours, and we're just going to calculate the mean of all the study hours, and we're going to fill any missing study hours values in that data frame with the average. All right, so if we go back and run this, we should see that study hours now shows as having 0 null values, right? Because we filled in the one missing value with the average. The problem with that is that it kind of makes your data not correct, okay? And the reason for that is because you don't know if the student got the average. They could have gotten less than Vicky, right? And pulled the whole average way down. And so sometimes it's better to just delete any null values in a data set, which is commonly what a data scientist will do. So let's go ahead and do that. So we're going to set our whole data frame here, and we're going to set it equal to df students, and then we're just going to use the drop in A to drop any rows that have null values. So to do that, we need to tell it which axis we're looking at. Rows are axis 0, columns are axis 1. Right? So if we set axis 1, it would drop columns. We don't want to drop columns, we want to drop rows. So we say axis 0. So if we do that and we run this, and then we go back and look now, we'll see that we don't have any null values, right? We've just dropped the rows that had null values in them. All right, so let's go back to where we were before when we were working with our arrays, when we calculated the mean study time and the mean grade, and we just printed that out. This is that same thing, just with a data frame. So the average study hours, 10.5, average grade, 49.18. So let's go ahead and get all of the students who studied for more than the mean amount of study time. So to do that, we'll take our data frame of students and we'll say, give us everywhere where the study hours was greater than the mean study time, okay? Let's go ahead and run this. And now we get everybody who studied for more than the mean amount of time, which I believe was 10.52. So this is everything that's more than 10.52. So it would be interesting to know here, for these people who studied more than the average, what was their average grade? Well, since this actually returns another data frame, as you can see here, we can just say for this grade column, give us the mean, right? What is the mean grade for everyone who studied more than the average amount of hours? So if we run this, we see 66.7. If we assume that a 60 is passing and the mean is 66.7, it would be nice if we could go ahead and flag in the table who passed and who failed. So we want to add a column to this data frame, which just says whether or not someone passed. So to do that, let's create a variable called passed. It's going to be our new column. And then we want to use this thing called series on PD. And you see the little yellow squiggly? It's because we haven't imported pandas. We did, but then we deleted that cell. So let's go ahead and put it back here. There we go. And in that series, what we want to do is just say from the data frame here with the grade, was the grade greater than or equal to 60, right? This returns a true if it was and a false if it wasn't. And it puts those trues and falses in the past variable. And then we want to take that data frame and we want to concatenate here this past column onto the rest of the data frame, adding a new column. So we're going to say we want to take the students here and we want the past column, and then we can take this opportunity to rename it and just make it say past here with a capital letter. And then finally, we need to tell it what axis. Are we trying to append a row or are we trying to append a column? Remember, rows are axis 0, columns are axis 1. So we'll say axis equals 1. So this should append a new column to our data frame. So let's run this. And then let's go ahead and come back to our data frame here and refresh. And look, we have a new column with a false or true about whether or not someone passed or failed the test. Now, because data frames are designed for tabular data or data that's in tables, we can perform all sorts of operations on it. For instance, we could put students into two groups, those who failed and those who passed, and look at the data that way. And that's called a group by. So let's do that. So in our data frame here, we're just say group by. And then what do we want to group by? Well, we want to group by the students, and we have that new past column that we added. Very handy. And then we want to get the count of how many passed or failed in each group. So if we run this, it tells us who passed how many and how many failed, but it does it in the table format, which is kind of hard to look at. So if instead we just take the name, right? If we group by just one dimension, the name, and we run that, then we'll actually get just one set of numbers here. 15 people failed and 7 passed. Crazy hard test. Now, what if we wanted to know for all of these students, what was the average study hours in grade for those who passed and those who failed? To do that, we can just print out our data frame here of students and use the group by. And we want to group by that past column. And then we want to know, though, from that, we want to know the mean of the average study hours in grade, or the average study hours in grade. So we could look at the grade and then say mean like this, but this will only give us the mean. If we want to get the study hours and the grade and the mean of both of those. So to do that, we want to take our data frame of students, we want to group by, and we want to group by whether or not those students passed. But we want the mean of both the study hours and the grade. Well, because we know that this is actually a data frame itself, when we group it, we could say grade and then give us the mean. And if we run this, it actually will give us that. But if we want the average study hours and the grade, how do we do that? We can actually do both of those at the same time using this array syntax here and saying, give us the study hours and give us the grade, and calculate the mean of both of those. So if we run this, you can see that we now get the average study hours for those who failed, 8, and those who passed, 14, and the same with the grade. So we can do both of those things at the same time using that syntax. So the last thing I want to show you here is that data frames are really versatile, and you can do a lot with them, including like sorting the data in descending or ascending order. Now, these data frames that we've been looking at, they're really versatile, but one of the things you might have noticed is that when you alter a data frame, you have to assign the value back to the original data frame. If you make a change to the data frame and you don't assign it back to itself, it doesn't actually affect or change the data frame. So what we can do is come in and say our data frame, and then we set it equal to itself. We're going to sort it. Let's say we sort it. Let's say we want to sort it by grade, and we want to sort it just ascending by grade. So let's go ahead and run this. And then let's come back to our data viewer and refresh. And we should see, yep, Vicky and her terrible grade there at the bottom. sorted by grade. If we wanted to sort by name or study hours, let's say study hours. And then if we wanted to do it in reverse, right, we wanted to say highest to lowest, highest first, then we would say ascending is equal to false. And if we run that, come back to our data frame, we should see study hours, the most at the top, descending here. And we do, descending. Something that data scientists do a lot is work with charts and graphs. And this is because when you're working and trying to identify complex patterns in data, it's easy to see if you can look at it. It's hard to see if you have to examine the numbers themselves. So charts and graphs help the data scientist do that. And we're going to take a look at how they do that now. So the first thing we're going to do is we're going to start with the data set, which is exactly the data set that we were exploring before with student data. We'll go ahead and run this, and this will pull in the grades CSV file, which we already have, but it'll get pulled in again because we've made additional requests for it. See right there, grades CSV.1. And then here, we're pulling in the grades, putting that in a data frame like we talked about, adding that passes column, whether or not they passed or failed, and then just printing out the data frame here. So it's exactly what we had before when we were exploring the data and learning about data frames. By the way, when I jump over to these CSV files here, you might notice that they're different colors, and this is powered by an extension called Rainbow CSV. You might want to check that out right here. So one of the cool things about Visual Studio Code is extensions, and there are tons of extensions for those of you doing data science, working with data, one of those being Rainbow CSV. All right, so we've got our student data. Now we want to make a chart or a graph. So to do that, we're going to use a library called Matplotlib. And again, if you don't have this installed, you can just in your terminal run conda install matplotlib, just like this, and that will install it. So if you run this and you get an error, try installing matplotlib in either Python using pip, or if you're using Anaconda like I am with conda install. So first, let's pull in matplotlib here, and then we're going to import pyplot, which is the plot. Plots are the charts as PLT, and that's what we'll call it here, the variable PLT. Now, what we want to do is create a bar chart here to look at this student data. And along the x-axis, we're going to put the student's name, okay? So name across the bottom, and then we want their grade across the side. So you would think that the y-axis would be called y, but it's not. When you're using Matplotlib, the plot item here, it's called height. I'm sorry, I didn't name it. And here we're going to put the grade for the students. And with that, we can just go ahead and say plt.show, and this should be all we need to create a bar chart of the students and their grades. And there we go. We have a bar chart. It's not easy to look at, but there it is. So let's take a minute and customize this chart and make it a little easier on the eyes. So let's start customizing here. Let's add a title to this chart, which is called student data, student, I tell you what, let's call it student grades, more descriptive there. And then let's add a label to the x-axis, which is just x label. We'll call this name. And then the y, which was height before, is actually now y label. It is y label, and we'll call that grade. And then the most problematic thing with this chart is that these X ticks are all running together and you can't read them. So if we turn them 90 degrees, they'll be a lot easier to read. So let's go ahead and do that. Let's say plot.xticks, and then we're just going to say rotation equals 90. So we're going to rotate them 90 degrees. So let's go ahead and run this. And now this chart's a whole lot easier to read because we can actually read the names on the bottom. And there's our favorite student, Vicky, with that horrible score. So we can also do things like change the color here. So if we change the background, say, excuse me, not the background, but the color of the bars, this will change the color of the bars to orange. So we have a lot of control over the charts and the way that they look. When you're working with charts, what we've got here is something that we've called a plot, but it's important to be specific. Plot is actually the chart. That's the plot. The whole thing itself, if we include all the way out to the edge, that's called a figure. Now the figure can have multiple plots or charts within it, and the figure is created for you automatically if you don't specify it. But if you do specify it, you get a lot more control over the size and shape of the chart. So up here at the top, we're just going to define a variable called figure, and then we're going to say that that is a plot figure. And then once we do that, we can start to change the dimensions of the plot itself. And we can do that with fig size. So we might want this chart to be wider or taller, just changing the dimensions. Now the fig size takes two variables, a width and a height, but they're in inches. So for instance, if we wanted a chart that was 10 inches by 4 inches, 10, 4, but because we're dealing with screens, we don't think in inches, we think in pixels. So one thing that you can do here is, because the DPI is 100 by default on these plots in Matplotlib, you could just multiply by 100 to get the pixels. So this would be 1,000 pixels by 400 pixels. If we wanted something that was 1280 by 720, that would be 12.8 by, that's right, 7.2. And we actually don't need to change anything else. If we just go ahead and run this, it will resize that chart to that size. So that's an important thing to know, is just how you make charts bigger or smaller with Matplotlib, and you do that with the figure and fig size. Okay, now as we said, this whole thing is called a figure, and a figure can have multiple plots. Those are charts. And that's commonly done because it helps us visualize data, and we're going to do that now. When we want to have multiple plots in a figure, we need to use the subplots item on the plot element there. And then where the fig size is, the first thing we need to tell it is how many rows and how many columns this figure is going to have. So in this case, we want to have 1 row and 2 columns. And the fig size is a little bit big here. Let's take this back down to 10 by 4 or 1,000 pixels by 400 pixels when you don't change the standard DPI. Now, we no longer are working directly with the plot element, and instead we're working with an axis element, all right? So that actually is returned by the subplots here along with our figure. And then we'll just say on the first axis, okay, we have 2 columns, 0 and 1. So we're gonna put a chart in the first column, which is AX0. A chart in the second column will be AX1. So in AX0, we're gonna put a bar chart, and the rest of this pretty much stays the same. Now we're no longer working with the plot element, and instead we're working with this AX0, right? That's where we're defining the plot, and instead of title, it's set title. And instead of all this stuff here, we're just gonna have this AX0 like we did before down here. And instead of X ticks, we're gonna say set X tick labels. And then inside of that, we're gonna say df students dot name, and they're going to rotate the labels 90 degrees just like we did before. And this gives us basically the same bar chart that we created. Now we want to create a pie chart to show the pass and fail totals. We're going to put that next to the bar chart. So to do that, we're going to get a total count of all of the passes. So a count of how many people failed and how many people passed. So to do that, we're going to take our data frame and we're going to look at the pass column. And in order to sum up all of the people who passed, all the trues and all the falses, what we need to do is use the value counts method here, which will give us a sum of all the trues and a sum of all the falses, 2 values. And then we want to pass those in and make a pie chart. So on the axis 1, which is the second column, we're going to create a pie chart. And in that pie chart, we're going to put the pass counts as the data that we want graphed. And then for the labels, we're just going to use the pass counts as well, because that's going to tell us true or false, and that's all we need to know here. And then just like with the bar chart, if we want a title, we can call set title here and pass in a new title. Let's call this passing grades. Perfect. And then finally, we're just going to call fig.show, right? Because we don't have a plot element anymore. We have a figure element. Okay, so let's go ahead and run this and see what we've got. All right, we got an error. We did get charts, but one of them didn't render and we got an error. But this is great because it gives us a chance to debug this and see what went wrong. So if we come up here to the top here, we can see this, which is called a stack trace. And we can see it's telling us line 11 here, this line, this label right here, it's telling us got an unexpected argument label, okay? And that's because it's labels, not label, right? And this is what makes programming kind of tedious sometimes. It's because you have to get this exactly right. So let's change that, run it. And now look, we have our passing grades on the right as a pie chart and our student grades on the left, 2 plots, 1 figure. All right, now it's worth noting that charting and plotting is so foundational to data science that you don't even need to use Matplotlib directly. It's kind of built into the data frame itself. So we can actually plot this or chart this directly from the data frame. So let's call df students, and then let's just say that we want to do a plot. What kind of plot? Well, we want a bar plot. On the x-axis, we want the name, and in this case, it is the y, not the height this time, which is nice. So on the y, we want what? We want the grade, And then we can actually set the fig size here as well. So let's set that equal to 10 by 4 seemed to be a good one. And then just like with the previous chart, we can set the color. Let's set it to something else here. This is actually all you need to create a nice bar chart. Really easy to do directly off the data frame. All right, now it's time to get into some actual data science here and figure out what's going on in this data. And what we want to do is take a look at these grades. And something that data scientists are often interested in when looking at data is the distribution of that data across the sample. Now, what's a sample? The sample is the data that we have, okay? The grades. The grades here are our sample. And then there's the population. The population could be any student who might ever take this class. So we look at data for the sample because we can't look at the entire population. And then we make an assessment or a judgment about the entire population based on the sample we have. The larger the sample and the more data points, the better our prediction can be for the entire population. When we examine the distribution or how the data is spread out across the sample, a great chart for doing that is called a histogram. So in our notebook here, let's create a histogram. So let's get some data here. We'll just call it grades, and then we'll just pull in from our dfstudents.grade column. And then let's create a new figure. And then we're going to just say that we want to plot with a new figure. And this allows us to set the fig size, right? And then we'll just make that 10 by 4, I think is what we've been doing so far. And then we're going to use the plot item to plot a histogram. We're just going to tell it that we want a histogram, and we want the histogram to be the grades, the data that's in the grades variable there. Now, just like we did before, we can customize this. Let's add a title. Let's just call it data distribution. And then let's go ahead and set our X label. There we go. And we'll just say that this is the value. And then we'll set our Y label. And this is the frequency at which this occurs. And then let's just go ahead and show this figure and run this. And we get a histogram. So let's talk about what we're looking at here. The histogram shows the distribution of the data, again, across the entire sample. So from 0 to 100, this is where the data falls. So you can see that most of the grades are actually right between about, what, 30, 40, the low 40s and 60, right? Maybe mid 40s and 60 right there. So most people scored between about a 45 and a 60, and that's why that's the tallest point. And then over on the very right, you have the people that scored the highest grades, which is only a few of those. Then over on the left, you have Vicky, who's bringing the whole average down. All right, so this histogram is a symmetric shape with most of the data being in the middle and the fewer being out on the edges, which is quite common when looking at sample data for a population. So another thing that data scientists do when looking at a histogram like this is try to define what's called the central tendency. And that basically means what's the middle point of the data. Now there's a couple different ways that you can measure this. One of them is something called the mean, which is an average. Another one is called the median, which is the number that is right in the center. If you line up all of the data from lowest to highest, what's the number that's right in the middle, equally from both ends? And last is the mode. And the mode is the number that occurs most often in a sample. So let's go ahead and add that to our chart here and see if it tells us anything different. All right, so right here, before we actually plot our figure, let's go ahead and get the min value, which is our students.grade.min. So next, we're going to look for the max val. We're going to set that equal to dfstudents.grade.max. And as you can see, these lines are starting to look very similar, and we actually need the mean, the median, and the mode. So in VS Code, we can use a shortcut here to do that, where we copy down lines, and we do that using Option-Shift-Down. And that just copies the line down, and we can do that 2 more times here, right? So here, instead of max val, we want, let's say, the mean, and then let's come out here to the edge and get the mean. And then for this next one, let's do the median. Actually, just call it, there we go. And then pull in the median. And all of these are built-in functions right on the data frame, which is really nice. And then the last one is the mode. And as you can guess, come out here and ask for the mode. The one difference with the mode is that you might have multiple numbers that occur the same amount of times, right? So maybe the score that occurs the most is 65, and then the score 68 also occurs that same number of times. And so because of that, mode is a list of items. So we need to make sure we get just the first item just by asking for that 0 placed item there. All right, so let's go ahead and print these values out so we can actually look at them. And then we want to add this to our chart. So to plot lines on a histogram, you use the AXV line method here. And this adds a line. We need to tell it the line, the value that we want to add here is the min value. And then we can do things like specify the color. Okay. Now, because we're going to need a line for min, max, mean, median, mode, again, we can just use the Option Shift down or Alt Shift down on Windows key to copy lines down just like this, right? So we can make this one, this is the min, we can make this the max val, it can also be gray. Let's make this one the mean val, and let's make it cyan. And oops, I capitalized a V here. And we get that nice squiggly to tell us that it doesn't recognize. If you see that squiggly, if we actually mouse over, it'll tell us it's not defined, which means we used the wrong variable name. So let's go ahead and correct that. And then we can make this one the median value, and let's just make that red. And then lastly, let's take this and make this the mode value, and let's make that yellow, should be fine. Now that we've done all of that, let's go ahead and run that again and check out our chart. So now we have a histogram and we have our lines here. So if you remember, the gray line is the min, this gray line is the max, this is the mean, median, and mode. And in our sample, they all happen to be in the middle, right? We could pretty much tell that by looking at the histogram. Some histograms aren't this neat. It's not as easy to see, so it's helpful to chart those lines. In our case, they are all right smack dab in the middle. That is the central tendency of this sample. Now, another chart that data scientists use a lot to examine central tendency is something called a box plot. So let's make one of those. So let's go ahead and define that grades variable again. We actually don't need to do this because it's already in the notebook and it will remember from previous cells, but let's go ahead and do it just so that we don't get confused about what data that we're looking at here on the grade. And then let's go ahead and create a new chart here, a figure. We'll say the fig size is 10 by 4, just like we've been doing. And then let's go ahead and add a box plot, just call box plot there. And we want to pass in that grades data. Perfect. Then we can set the title. Oops, title. There we go. We'll just call this data distribution. And then we'll go ahead and show the figure. All right, so what does a box plot look like? Let's find out. This is a box plot. What a box plot does is it shows you how the quartiles of the data are split up. What does that mean? It means that if you separated the data into 4 equal groups, where would they be in this chart? The middle 2 quartiles, right? So 50% of the data is actually here between about 36 and lower 60s. Can't tell exactly. 50% of the data is here. 25% is here. 25% is here. So this is called a box plot. These are often called whiskers, and this is something else data scientists use to measure central tendency. It's often useful to combine histograms and box plots together to get a clearer sense of the data. So to do that, I'm just going to copy in a bunch of code here. And this is code we've already written, right? Min, max, mean, mode. And then we're using the subplots. So 0 is our histogram with our lines on it. And then 1 is the box plot here. And then we're just showing that. That's it. We're not doing anything special here. I just want you to have me see me write that code all over again. I'm going to remove this for a second and run this. And then we'll see that we have both of those charts now in the same figure. But the box plot doesn't help us much because this chart goes this way and this chart goes this way. And that's why I removed this value here up here where it says box plot. So what we can do is just say vert and just set that to false. Let's run this again, and this will display the box plot horizontally, just like the histogram, which helps us understand it a little bit better. And again, we can see here that it matches, right? Central tendency is right smack dab in the middle, 50% of our grades being right around here, just a different way to visualize that central tendency. Now, we talked about samples and populations and how a sample is a subset of the population. It's the data that we have, and we try to extract insights about that sample so we can make predictions about the population. If we have enough samples, then we can calculate something called a probability density function that will let us make sort of assumptions about the population at large based on the sample. The pie plot, which we've been working with in Matplotlib, provides a very handy plot to do just this. So let's create a function to do this, actually. When you have a lot of code, it's very nice to put it inside of a function, and the function just sort of encapsulates all the code that goes together, and you can call that function later on. So here, let's go ahead and create a new figure, and we'll say plot figure, and then fig size. You should be an expert by now at these figures. And then we'll go ahead and say that for this data here that we've passed in, we want to plot and we want the density. And remember, we can call the plot directly on the data because it's a data frame, and data frames have that charting built in. And then we can set some additional things here, like we could add the title. So we'll just call this data density. There we go. And then lastly, we just need to show this thing. And then how do we call this function? Well, we just sort of call it. So we'll just click show density, and then what data do we want to show up on the plot? The grade. So let's call it df students and the grade, and we'll pass that in as the data. So let's go ahead and run this. And this is our probability density, also known as a bell curve. You've probably seen these before. So you can see that the grades are distributed right here, right, with the outliers on the edge. It looks just like the histogram. So from this, we could make some sort of assumptions about the data, or the grade, the class, the test. We could say the test was too hard if more people got a 50 than got, say, a 75, and maybe we want to move this over to the right, so we want to grade on a curve. But that's not really the kind of conclusion that data scientists are often after. You don't need charts and graphs to determine if you need to grade on a curve. Teachers do this all the time. What a data scientist would do is actually look at how the different points in the data relate to each other and figure out if there are some predictions that we can make about the population based on the sample. And that's what we're gonna do. So first, let's just create a new notebook here, and we'll just call it real world, because we're gonna do some real world analysis here. And then let's go ahead and start with this distribution plot that we had. So we'll go ahead and run this. This code should make sense to you here. Let's scroll down, and what we'll see here is our data frame, and then below that, we'll see the histogram that we had and the box plot, right? With the mean, median, and mode all right in the center. This should look very familiar to you. Okay, so now what we want to do is look at a different set of data, because we've been looking at grades, so let's look at study hours. So to do that, let's call our show distribution function, and this time we'll pass in the data frame of students and the study hours instead of the grade. And we've got a capital T, which is wrong there. Let's go ahead and run this. And let's look at the histogram and box plot for this one. All right, so this histogram and box plot looks quite a bit different. So you can see that the whiskers on this plot start at about 6, and that 0 over to the left here on the bottom indicates that we have statistical outliers, less than 6, but they're outliers. And an outlier means that it's not representative of the normal sample here. And that could be for a variety of reasons. So if you had a 1 here, 1 hour, maybe that's a typo. They meant to put 10 hours in the data set and they got 1. Or maybe there's something else that caused the student to only study for 1 hour. We don't know. But we can safely say that this is a statistical outlier and it's not representative of the rest of the data in our sample. So one of the things that we can do here is we can just remove it. So let's go ahead and take our students, right? And then from that, let's pass a filter. You should remember this from the first video. And we're just going to take it where the study hours is greater than 1. And then we want from that the study hours. And this will give us the study hours that are greater than 1. And then let's go ahead and do our distribution again. And we'll pass in that new filtered set of study hours. And now our box plot goes all the way to the left and the right, right? Extends the whole range because we've gotten rid of that statistical outlier. Now, normally in data science, you don't want to do this. You don't want to just remove statistical outliers without being able to explain why they are there. Because the thing is, if we expanded our sample to the entire population, we might find out that a lot of people only study for 1 hour and it needs to be in there. So just something to be aware of. So now let's look at the density for this distribution. So again, this is code that we wrote in the last video. This should look familiar to you. If we run this, what we'll see is that bell curve that we generated before, but this time for the study hours. And this bell curve looks quite a bit different. This bell curve is what we call right skewed. And that means that most of the data is on the left side, right? Or less than 10 study hours. And so it causes the right side of the chart to be longer, to have a long tail. And those 3 lines in the middle are the mean, median, and mode there, which you can see are all sort of right around the middle point. So we've talked about the importance of knowing where the middle point is in the data. But there are some other measurements that data scientists use to gain insights about the data. These can be the range, or the difference between the minimum value and the maximum value, something called the variance, and something called the standard deviation. Let's talk about those. In statistics, variance is described as the average of the squared differences from the mean. What does that mean? Well, let's calculate it and it'll actually make a lot more sense. It's not that complicated. So what variance is it's sort of a measurement of how far the data is spread out across the sample, or how far away it is from the mean being the average. So first, let's just get the mean here. We know how to do that, right? So let's get our students, our study hours here, and then we'll just get the mean for the study hours. Now let's go ahead and calculate our variance. We're just going to start at 0 and we'll calculate it. And then what we're going to do is we're going to loop over all of the study hours. And we can do that here just like this with this for loop. And this will loop over all of the hours values in the study hours column. Let's just go right through that whole column. And then once we're in there, what we need to do is we need to subtract the hours from the mean. Okay, so for each row, we're going to subtract the hours from the mean. Some of those values are going to be negative, right? Because if the value is above the mean or the average, if the average is 10 and you studied 15, that's a -5. So to account for this, what they do is they square that number, which always gives us a positive number. And then what they do is they take the variance, they add all those numbers together to get what they need first off for the variance. So we're going to say variance equals, and then we're going to just add to what the variance already is. And we're going to say plus, and then order of operations, put all the stuff in parentheses so it does the right side first. And then the last thing that we have to do to get the variance, so variance actually equal to variance divided by, so this number we're calculating in the for loop divided by the total number of rows that we had in the loop. So we can get that by doing df students. And if you remember before, there's a shape method that we can call here that gives us the rows and the columns. And so if we just do 0, that gives us the number of rows, right? And so then let's just look at the variance value here. So we'll run this and we get 11.607380. What does this mean? Actually, it doesn't mean anything to us. Variance is a measurement that often means something to statisticians, but when we're working with the data, it doesn't mean a lot to us, and that's because we squared those numbers. So what statisticians do is they use a different measurement called the standard deviation. You've probably heard of the standard deviation before. And the standard deviation is just the square root of that variance. So to get the square root, let's just import the math package here, and then we'll just ask the math package for the square root function of our variance, right? And that should give us the standard deviation. So let's run this. And there we go, 3.4. Now what this means is that for one standard deviation, the value is going to be 3.4 away from the mean, either above it or below it. But what does that mean? Well, there's a number that you need to memorize here, and it's 68%. Just remember that number in your brain. 68% is the number that statisticians use for a normal distribution, right? When that curve looks relatively normal, we can say that 68% of the values in that curve will fall in one standard deviation. So 68% of the hours, the study hours, are going to be 3.4 above the mean or 3.4 below the mean. And that's the standard deviation. Fortunately, we don't actually have to calculate these things by hand, even though we just did. So instead, what we can do is let's loop over our columns here in, so we're going to loop over the grade column and the study hours column. And that's what this for loop is going to do. And then inside of that, whoops, Visual Studio Code telling me that's wrong. Let's fix that. And then inside of that, we're just going to go ahead and get the column from the data frame here. It's going to be either grade or study hours. This allows us to do that. And then let's calculate the range, right? Which we said was the max minus the min. Okay. And then let's go ahead and calculate the variance here, which we can just do like this, right on the column, and then we get the standard deviation the exact same way. And then let's go ahead and print out what that standard deviation is here, and the range and the variance. Let's run this. Okay, so we can see for the grade here that the range is 94 and the standard deviation is 21. And what that means is that we can do this. We can say, let's just print this out so we can actually look at it. But we can say 68%, right? That's the magic number you were going to store in your brain of grades will fall between, right? And then we need the mean minus the standard deviation. So let's just say df.students.grade.mean minus dfstudents.grade.standard deviation, right? That gives us the lower end, and then the upper end would be this same thing here. Let's go ahead and just copy this over. Okay, put this at the end, and then change this minus, just reverse this sign. And then we can actually look at this and it should make more sense. So 68% of all grades will fall between 27 and 70, okay? And that's one standard deviation. And these calculations are actually all built into the data frame. So we can just describe the data frame here like this as a method. And that will tell us for each of these columns what the mean is, what the standard deviation is, what the quartiles are, the min and the max. Okay, so if you've made it this far, you now should understand concepts about the distribution of data, variance and standard deviation, range, mean, all of that stuff. Congratulations. Now that we know that, we can use that to examine relationships between variables in our data set. And this is where things start to get really interesting. So what we can do is define a new data frame here called df sample, and we're just going to set that equal to df students, and let's pull out where the study hours is less than 1, okay? And then let's go ahead and look at this data frame. In our data frame, we have a couple of different kinds of values, okay? We have numeric values and we have categorical values. The numeric values are study hours and grade, and the categorical values are name and pass. We can actually compare numeric columns to categorical columns to get some insight, and I'm going to show you how to do that. So first off, let's compare the study hours numerical value to the pass categorical value. So to make this comparison between these two values, let's go ahead and use a box plot. So let's go ahead and use our sample data frame, and we can call the box plot right off of the data frame. And then we need to tell it what column is it that we want as a bar, and we're going to say study hours. And it's got this nice little by a value that we can pass here, and we're going to say give it to us by pass, and I'll show you what that does here in a second. And we'll set our fig size equal to 8 by 5, which would be what? 800 by, that's right, 500 pixels. Let's go ahead and run this, and here's our box plot. Now, you can tell just by looking at this that the more that you study has a direct correlation with whether or not you passed the class or the exam. It's just readily apparent from looking at it, and probably common sense. You could have guessed that without a chart. But the real insight here is that the study hours might be a good predictive measurement for whether or not a student is going to pass the class. Now let's examine our numerical values and compare those. So let's take our sample data frame here and let's make a plot. And along the x-axis, the bottom, we want to have the name of the student, right? And you should remember this from the box plot we made in the previous video. Along the y-axis, I want to have 2 bars. We're going to have 2 bars for every student, 1 bar that represents their study hours and 1 bar for the grade. So to get 2 columns into the y-axis, we just need this array syntax here, and then we'll tell it, give us the grade and give us the study hours, okay? And then the kind of chart we want here is going to be a bar. And let's go ahead and set our fig size here equal to, let's just keep using 8 by 5. Perfect. All right, let's take a look at this. Okay, so we have a bar chart here, but it's kind of meaningless. And the reason it's kind of meaningless is that the scales for these numeric values are different. A grade can be from 0 to 100, whereas study hours don't go that high, right? I mean, study hours might be 20 is our time. In fact, we can go back up here and look and see when we described our data frame, what was the max amount of study? 16. Okay, and the max grade is 97. So they're not on the same scale, so we can't actually compare these values like this. So what we need to do instead is normalize the range for these values. And there's a lot of different ways to do that. We're going to use one called a min-max scalar. And what the min-max scalar does is it takes the range and it just normalizes it to between 0 and 1. 0 being the bottom, 1 being the max. And it normalizes both the grades and the study hours so that we can actually compare those two. So let's go ahead and create a new cell here. And we're going to use this scikit-learn pre-processing here, and then we're going to import this min-max scalar. There it is. All right. So let's go ahead and create the scalar, and we want a min-max scalar. And then we're going to take and create a new data frame, which we're going to call df normalized, because we've normalized this data. And we're going to take our sample data here. Okay. And then what we want to do is we want to pull off the name, grade, and study hours columns, because that's what we're using in our bar chart. Anytime that you specify multiple columns that you want from one data frame to another, you got to use this kind of goofy double bracket syntax. All right, so we want the name, we've got the grade, and we want the study hours. Okay, and then what we're going to do is we're just going to call copy, which is going to copy all that into the new data frame. It's a different way to create a data frame from another data frame. We're just selecting specific columns and copying the data over. Now let's go ahead and normalize this data frame. So let's say df normalized, and then let's tell it what columns we want to normalize. And remember, when you're specifying multiple columns in a data frame, you got to have that goofy syntax there. So we want the grade and we want the study hours. Okay. And then what we want to do is we want to tell it that these columns are equal to, and let's call that scalar, that min-max scalar. And we're going to say fit transform. Okay. Because we're using the min-max scalar, and then there, we're going to pass in the normalized data set here with that goofy syntax. So normalize the grade and the study hours. Okay, and then the last thing we want to do is plot this out. So let's take our normalized data frame, call the plot here, x is name. This is exactly what we were doing before. Y, since we want both grade and study hours, we need the bracket syntax here, study hours. The kind is going to be bar, and the fixed size we will make 8 by 5. Okay, let's go ahead and run this. And now we've got a bar chart where we can actually compare these values. And again, you can tell just by looking at the chart that the number of study hours is directly correlated to the grade. I mean, you can tell that just by looking. The more hours you study, the higher the grade tends to be. If you study for just a few hours, or like this person here, the grade is really, really low. So there seems to be a correlation between study time and grade. And there is a statistical correlation value that we can get that will tell us the strength of the relationship between the number of hours that you studied and the grade that you got. So to do that, let's create a new cell here, and let's take our normalized data frame. Let's get the grade column here, and let's ask for the strength of the correlation to this other column here, which is study hours, okay? And then we'll go ahead and print that out. That's a 0.91 or 91% correlation, which is super high. The correlation value goes from -1, which means they're probably not at all related, to 1, which means statistically the probability is they are highly correlated. Correlation goes from a value of -1 to 1. -1 being they're probably not related at all, and a 1 being that there's a really good chance that these two things are related. And that 0.91 is almost a 1. That's a very high correlation. Now, you may have heard the phrase correlation is not causation. And this is really important to understand because it's going to be super tempting for us to jump to the conclusion here that the more that you study, the higher the grade that you're going to get, that they're directly related. And even though the causation is high, that's not necessarily true. And we can actually see that just by going the other way and saying, well, because of the strength of the correlation, they studied a lot because their grade was high, which doesn't make any sense at all. So let's continue to examine this relationship here. Let's go ahead and take our sample data frame and let's create a new kind of plot here. Let's create a scatter plot. Let's set the title here to study time, if we can spell, versus grade. And on the x-axis, let's put the study hours. And on the y-axis, we'll put the grade. All right, let's go ahead and take a look at this scatter chart. Now we can put a line here to better see the relationship between the dots, the grade, and the study hours that shows the trend if we use something called a regression line. Now, stop for a minute. Do you remember when you were in high school and you took algebra and you learned about slope-intercept form? Remember that equation? Y equals mx plus b, and you thought, when am I ever going to use this? Well, hold on to something because we're about to use it. So our formula for slope-intercept form was y equals mx plus b. Please don't turn the video off. This is going to make plenty of sense here in a second. So in this equation here, y and x are the coordinate variables. We actually already know what the x and y values are, right? X is study hours and y is grade. What we need to do is calculate the slope of the line, which is m, and b, which is where it crosses over the y-axis. If we have all those values, we can calculate a new y point for the line based on each of our x values. And we actually call that variable fx because it's actually going to be a function that we pass these values into. It's going to give us back a new position so that we can draw a line of best fit, or the line that's best fit for the points. We also have to deal with something called an error. And the error is the difference between the actual y value and the new y value that we calculated for the line, the regression line that we're going to draw. And the way that we calculate the error is that we actually take and we find the difference between the actual y value and our new calculated y value, and then we square it. And remember, we square it because sometimes it will be negative, and this gives us a positive number. And this line gives us a line of best fit, and it's actually called a least squares regression. And the reason why is because we're trying to minimize the error. The error is squared and the line is a regression line. Still with me? Now, fortunately, you don't have to calculate any of this stuff yourself. You just have to conceptually know that it exists and how to use it to draw that line. Python will do the rest for you. So let's go ahead and use this SciPy package here and import the stats from that. And then what we'll want to do is let's create a new data frame called df regression. And from that, let's get our sample. And then we want to pull out the grade and the study hours. So let's pull in the study hours here and the grade, and then we'll just copy those in. That's that goofy double bracket syntax we talked about. And then we want to calculate the slope m and the intercept b, okay? So we can do that by calling this stats.line regress here, okay? This gives us the regression line, and we just need to tell it, well, what line are you trying to calculate? We need the x and y values. What is the x value? So df regression, study hours, right, is our x value here. And then the y value, study hours. And then the y value is going to be the grade, okay? And this will give us the slope and the intercept. Now, unfortunately, it's going to give us a bunch of other variables as well. And we can actually see this if we mouse over. It's going to give us the slope, the intercept, the R value, the P value, and the standard error. So we can just go ahead because we need those variables or this function will fail. We'll get the R value, the P value, and the standard error. Even though we're not going to use those, we have to include them for this code to actually work. All right, so now on our data frame, we can have a new column that's going to be that new y value, and we can say that's equal to y equals mx, right? M times our regression of study hours, because that's the x, study hours, what, plus b, right? And that's going to be just out here plus b, because we already have the m and the b, which are being calculated for us. So let's go ahead and calculate our error here as well, or the difference between our new y value and the old y value. So our new y value we have called fx, and we're going to just subtract the other y value, which is the grade, and that will give us our error. And then let's go ahead and plot this. So let's do a plot. Let's make it a scatter plot. And this is the same scatter plot that we just made, where the x is study hours and the y is grade. So now we want to plot that regression line. How do we do that? Well, let's use the plot item here, and we're just going to tell it to plot. And what do we want to plot? Well, we want from the regression data frame, what we want to do is we want to plot the study hours, right? But the line that we want to draw here is from our regression data frame. We want that new y value. That's actually what we wanted to plot. And let's change the color here so we can see it a little bit better. We'll just make it cyan. All right, and then let's go ahead and show this, and let's see what we've got. Let's run this. And boom, there's our line of best fit. And hopefully this makes sense now. We used that slope-intercept form to calculate these new y values, and we connected all those new fxy values, and that makes the line. And that just shows us sort of the trend line here, so we can see that as study hours go up, so does the grade. Now again, we could have seen this visually without the line, but that's not always the case. Sometimes the line is very helpful to help you identify and visually see the relationship between these items. Now, I told you things were going to get super interesting, and here's where it's all going to come together for you. So you know these M and B values up here? I actually want to print these out, right? So let's just print M and B, our slope and intercept. So let's go ahead and run this. And we get 6.31 and minus 17. These numbers are important because we now have all of the information that we need to actually predict what a grade will be based on the amount of hours that someone studies. So here's how to write a function to do that. So we're gonna have a new function here. Let's just call it predict. And then we're gonna pass in the X value, right? The X is the number of hours that someone studied. So we're gonna pass in that X value. We're gonna calculate what their grade would probably be. So our M, if you remember before, we had the M and the B, right? So our M was equal to what? 6.31. It's right there above us, 34. The more decimals we include, the more accurate it will be. The B was equal to what? Minus 17.9164. Again, it's these two values here. And then what we're going to do is return MX plus B, okay? And that's going to help us predict the grade, which is that value on the line, right? That regression line, which is the line of best fit, which is most likely the grade that someone would get if they studied for a certain amount of hours. So let's go ahead and call that. Let's say our prediction here is, let's call our predict function, and we're going to pass in and say, well, what if they studied 14 hours? What would their grade be? And then let's just go ahead and look at our prediction. So our prediction is that if they studied 14 hours, their grade will be a 70. What happens if they study for, let's say, 20 hours? 108. So you can see here that we kind of need to cap this because it doesn't know that the highest grade you can get is 100, but essentially studying for more than about 18 hours, 95, right? So if you want an A in this course, you need to study for 18 hours. And if you've made it this far, you know a lot about data science, and you actually know something about machine learning as well because you just did it. You used a linear regression algorithm to make a prediction based on the amount of hours that someone studies. Thank you so much for sticking with me through this video series. Check the description in this video for more resources that you can go through on your own interactively to learn more about data science, machine learning, and artificial intelligence. Happy coding.